Okay, so in day 4 of chapter 11 here, I guess we could call it section 4, we're going to talk about some angles that are formed inside of a circle. And we've already talked about central angle. A central angle has its vertex at the center and it's equal to the arc that it intercepts. We've talked about an inscribed angle. An inscribed angle is sometimes called an on angle because the vertex is right on the circle itself. And we'll talk a little bit more about those at the end of this lesson as well. But today's focus is going to be primarily on what's called an inside angle. And an inside angle is an angle that's formed by two chords. Okay, so let's take a look at what this inside angle looks like. So here we have two chords that are intersecting in a circle. And if you look at it, angle 1 right here, this would be angle 1. The arcs that it intercepts are actually this one on the front and this one on the back. Now, an inside angle is equal to half the sum of the arcs. So the angle is equal to half the sum of the arcs. And sum, of course, means to add. So for angle 1, it'll be equal to half. And then we need the measure of arc AD on the front added to the measure of arc BC on the back. If we talk about angle 2, here's angle 2 right there, the two arcs associated with angle 2 would be this one on the top and this one on the bottom. So if we're talking about the measure of angle 2, the measure of angle 2 would be equal to 1/2. And then on the top, we have arc AB, measure of that. Oh, I'm going to make that a little bit clearer for you. So the measure of arc AB. And on the bottom, we have the measure of arc DC. And that's what we do for angles inside a circle formed by two chords. Let's take a look at some examples then. So here's our first example. And the angle AED would be, I'm going to call it X right here. So that's the angle we're looking for. Let's first identify the arcs. The arcs associated with it would be the AD on the front and the BC on the back. And recall that the measure of the angle is equal to half the sum of the arcs. So the angle is the X, and the arcs are the 45 degrees plus the 109 degrees. Now if we add those together, 45 plus 109 gives us 154. And if we take half of 154, we get 77. So that means the measure of our angle AED would be equal to 77 degrees. So that's how we do it for angles that are inside a circle formed by two chords. Let's take a look at just a few more examples. So here's example 2. This time we're looking for angle STR. Once again, I'm going to use X. So I'm going to call that X down there. Let's identify the arcs associated with it. We have the 112 here, and then we have the 186 up there. And then, once again, the new thing that we're learning is that the angle here is equal to half the sum of the arcs. So our X essentially is equal to 1/2, and then 186 plus 112. 186 plus 112 gives me 298. And half of 298 is 145. I'm sorry, 149. So the measure of angle STR would be 149 degrees. Not too bad. Let's take a look at a few more examples. Some of them will have a little bit of a change in them. Here's the next example. And in this example, we're looking for the measure of angle YWX. Since we already have an X in there, I'm going to use a different letter for it this time. So angle YWX, I'm going to call that little a. Now, the two arcs associated with it. Well, the two arcs associated with it would be this arc up here and this arc down there. Now, unfortunately, they didn't give us those two arcs. But we have a few things that we do know. We know that the total for a circle is always 360 degrees. So if I was going to take the sum of those two arcs, the measure of angle YX, arc YX, plus the measure of arc VZ, I could find that by taking the full circle, 360, and just subtracting the two arcs they gave us. So the sum of those two arcs, YX plus VZ, the remainder of the circle, comes out to be 360 minus 43 minus 81, comes out to be 236. And that is my sum. Recall that the angle is equal to half the sum of the arcs. So our little a will be equal to half of 236. So our little a would be equal to 118. And that would be the measure of the angle YWX. So the little difference there, the little change was they actually didn't give us the arcs we needed for our angle. Instead, they gave us the other arcs. But we were still able to find the sum of the two arcs we needed by subtracting from the full circle. Okay, so example 4 here. Now, what's different in example 4 is we're actually looking for an arc itself. We're looking for the measure of arc LK. So we're looking for this one right here. That would be the arc we're looking for. I'm going to use X to stand for that because we don't have an X in our problem. Now, the angle is equal to half the sum of the arcs. But the angle, we know, that's 62. That's the angle. So I can put the 62 degrees here, and then for the sum of the arcs, I'll put 74 plus X. Well, we've seen this situation before in an earlier section, and I've always recommended when the variable is in the parentheses with the 1/2 on the outside that you consider multiplying both sides by 2. So if I take 2 times the 62, I get 124. But more importantly, on the other side, that cancels that fraction, 74 plus X. And now I'll just subtract 74 on both sides, and my X comes out to be 50. So the measure of that arc LK would be 50 degrees. Arcs are measured in degrees, just to remind you. So the difference there was we were looking for an arc instead of an angle. Number 5. If you look at number 5, we're also looking for an arc. This time we're looking for the arc C through D to E. So C through D to E. And once again, they didn't use the letter X in the diagram, so I'm going to go ahead and use the letter X out there. Well, we have the angle. Here's the angle. We know that the angle is equal to half the sum of the arcs. So the 128 degrees will equal half. And then the sum of the arcs would be 73 plus X. Hey, this is like the one we just finished. And as I remember in that previous one, I suggested we multiply both sides by 2. 2 times the 128 gives us 256. We'll subtract 73 on both sides. we get 183. So the measure of our major arc, CDE, would be 183 degrees. Very similar to problem 4. Let's take a look at another example. So here's another example, and in this example we are looking for an arc. The arc is Q to T. So the arc we're looking for is this one down here. And they don't have an X in this problem, so I can go ahead and use X for it. I'm going to go ahead and call that X. But the problem is they didn't give us the angle we would like. We would like to have this angle right there. I'm going to call that Y. Now we can find that angle. So first we're going to find angle Y. And we're going to find that by using a linear pair. Something we learned about in first semester. We know that if we take 79 degrees and we add Y, we'll get a straight angle, 180 degrees. So the Y will come out to be 101 degrees. And now we can use the angle is equal to half the sum of the arcs. The angle right here, that was the 101 degrees we found, so that's the 101 right there. The sum of the arcs would be the x plus 95. And now it's just like problems 4 and problem 5. We'll multiply both sides by 2. 202 equals x plus 95. We subtract 95 on both sides. We find out that x is 107 degrees. So that means the measure of arc QT is 107 degrees. So the little twist, the little change in this one was they didn't give us the angle that matched up with the arc we were looking for. So we found it using a linear pair. Okay, I told you we'd be talking a little bit more about on angles. Remember, an on angle is like an inscribed angle where the vertex is on the circle. So we already talked about inscribed angles, and an inscribed angle was equal to half of the arc. There's only one arc associated with it. So if we're talking about angle 1, the arc that's associated with angle 1 is this one. So the measure of angle 1 will be equal to half the measure of arc AB. If we're talking about angle 2, the arc that's associated with angle 2 is this one out here. So the measure of angle 2 will be equal to half the measure of arc BCA. That's a major arc, so we have to use 3 letters. So just like an inscribed angle, any on angle is going to be half of its arc. Let's take a look at just a couple examples on that. So here's number 7. Now, at number 7, we're looking for the measure of angle DEG. DEG would be this angle right here. And I'm going to use an X for that. The arc that's associated with it will be this arc out here. That's the 308 degrees. So that means my X will be equal to half of the 308 degrees. So my X will be equal to 154 degrees. The measure of angle DEG is then 154 degrees, just like with inscribed angles. Let's try another example of these on angles. Okay, so we're looking for the angle D to B to C. D to B to C. So we're looking for this one. And I'm going to use X for it again. Now the problem is, the arc that goes with that one is this arc out here. They didn't give that to us. I'm going to call that Y. we can find that because we know a full circle is 360 degrees. So the y is going to be 360 minus 192. So the y is going to be 168 degrees. And that means that x is equal to half of 168 degrees. So x would be equal to 84 degrees. And that means the measure of angle DBC is equal to 84 degrees. So here they gave us the wrong arc. We had to make sure we found the correct arc. We did that by subtracting it from the full circle. Okay, one last example. So in this last example, we're looking for the arc from X to Y. So we're looking for this arc right here. And the problem is they didn't give us the angle. So first we're going to find the angle. And since they used X and Y in this problem, I'm going to call that A. Now, I find angle A using, once again, a linear pair. I know that 151 degrees plus angle A will equal 180. So angle A comes out to be, subtracting 151, I get 29 degrees. And I remember the angle equals half of the arc. Well, the angle I already have. The angle is 29. And I want to find the arc. And for the arc here, since I don't have the letter X or Y to use, I'm going to use a different letter. And for that arc, I'm just going to use a B. And to solve that, I'll multiply by, well, maybe I shouldn't use the B. I'm going to use a different letter so that it doesn't look so much like a number. So how about we use C? So we'll use C. And I'll multiply both sides by 2. 2 times 29, I get 58. So that would be our arc. So the measure of arc X to Y is going to be 58 degrees. So this very last one, we had an on angle. It was equal to half of the arc. This time we were looking for the arc, but they didn't give us the correct angle. We had to use a linear pair to first find the arc.